Hello, my name is Hadley from Team 14596 Accelerate, and today I'm going to talk a little bit about our robot design process, how our team designs and constructs our robots, and give some advice on how other teams can improve their design process along the way. So first I'm going to talk about our planning stage, how we plan out our robot before we go and start building. So before we go any further, I'd like to talk about the concept of idea bias. So idea bias is any bias towards or against an idea or design that you might acquire from any number of ways, from coming up with a design, from seeing somebody else do it that way. And it's just the idea that once you see an idea, or once you come up with an idea, it's going to be hard to come up with, or it's going to be hard to see a solution in any other way. This isn't always the case, but it can happen, and it happens quite frequently. And it can sometimes be a problem. For example, if one of your team members comes up with a way to solve a problem or solve a challenge, and it may not be the best way or the most elegant way, but it's the way that they think is the best, it can cause problems later down the line when it shows that there's problems with the idea or that it's just not the most efficient. Idea bias can be, or negative idea bias can be mitigated through certain techniques that we will go over in our planning phase. So the first step that we like to take is we have a brainstorming priming session where we go over our goals and break down the challenge at hand without discussing specific ideas on how to accomplish these goals. We do this to create an environment where everybody's on the same page for how, or for what we want to accomplish, without being bogged down with certain ideas on how you might accomplish a specific aspect of the game. So the first thing we do is we analyze the challenge. If it's an FTC game, for example, we will look through the rulebook, we will we'll read all the different ways that you can solve a problem, and we'll list them out on a board, and then we'll objectively see, like, hey, these three tasks are the optimal ones, these are what we want to pursue to score the most points. Then, once we know the point values, we're going to talk strategy, how we want to accomplish these tasks without specific designs. Let's say if it's a game where you have to deposit an element into a bucket, we'll say, okay, we want to pick up this element with one system and deposit it with another. Or we want to use some form of like lifting mechanism to deposit this. Or we want to use a shooting mechanism to deposit this. We'll give broad overviews of what we want to do without specific designs so that we can each independently brainstorm different ways to achieve these goals. When we're brainstorming, or when we're priming, we will never talk about specific solutions. We'll never talk about specific designs. This is just to give everybody a chance to think about it on their own without acquiring any bias towards a certain design. So the next step that we like to take is to make a design matrix based off of the criteria that we've discussed in our priming phase. So a design matrix is essentially a chart where we list off all of the criteria that we have for a certain element or a certain design that we use to compare to ideas that we come up with how to solve that problem. These will be things like the strategies that we discussed in our priming session, maybe certain specific things like, is the system fast, is it compact, stuff like that. And the idea behind a matrix is to help organize our ideas in a more binary way so we can see which idea that we come up with later on meets the most criteria. It's intended to be a tool to help choose ideas, not necessarily a all-for-one deciding factor. But if there is an idea that somebody comes up with that meets all of the criteria that you set on the design matrix, that might be something that you would want to pursue later on as a prototype. The next step, once you've primed yourself and made a design matrix, is to break into individual groups and come up with ways to solve the problems that you've given yourself. There are different ways that you can come up with ideas. You can just be inspired from yourself if you see the way that something could work that isn't based off of anything, it's just how you think you could solve it. That's one way you can come up with designs. You can find inspiration from either the real world or from different teams in previous years. An example of coming up with something from the real world is this intake mechanism that we used on the Ultimate Goal robot for our team. Our intake mechanism was based off of the intake found inside of a vacuum cleaner. It was just an idea that we came up with for collecting minerals off the ground, and it ended up working well. Or you might come up with inspiration from seeing the way a previous team's robot worked, like watching videos from the World Championship from a year where you're manipulating a similar element to that season. You can see how previous teams did that so that you don't have to spend time brainstorming on your own. You can just sort of bounce off of what they've come up with because it's been proven to be effective. The most important thing to do when you're researching and coming up with designs to share with your team is to write everything down. Even if it's a crazy idea, even if it's sort of off the walls, bonkers, maybe silly, it's a good idea to have everything written down and to share everything, because even if you don't see any benefit to that design, somebody else might see something in it and use your idea to create something else. It's all about sharing ideas and coming up with as many things as possible independently so that when you come together, you can debrief and you can work with a giant pool of information. Our next step is to come back together and present all of our ideas that we come up with individually to the group. We'll list them all out on a whiteboard and just sort of get everybody in the loop with all of these different ideas. Then we will fill out a design matrix using all of these ideas. We'll plug them all in and we'll see which ideas meet the most criteria or which ideas just sound the most reasonable. Once we have our list and we've narrowed it down to like one or two ideas that seem like they're the best, we'll start our prototyping phase and start pursuing these ideas to see if they have more merit and just start developing them. The last thing that we do in our planning phase is we start planning out a space allocation for different components. Space allocation is important because it ensures that designs aren't going to be too big, they're not going to clash with each other on the robot, and it's important to have an idea of what space you have to work with before you start designing so that you don't go overboard. You don't design something that's too large or doesn't fit or that collides with somebody else's part. Smart space allocation will be modular so that it's easy to remove certain components for modification and for repair. It's just important to plan everything out, or plan out what you're going to do on the robot so that you don't collide when you're putting it all together. Once we've planned out what direction we want to bring our robot in, we'll start prototyping our designs and developing them to a more substantial phase. When making your first couple prototypes, it's a good idea to use readily accessible materials just to get something cranked out, to make a quick, rough and dirty model to see how it's going to work with future iterations. Some good materials to use for a first prototype include cardboard, particle board, or 3D printed parts, which I'll go over in a little bit. Wood is also a good option for a first prototype, just something rough and dirty so that you can get your hands on basic design. An important thing to keep in mind when prototyping is to keep it simple. It's really, really easy to go overboard with the design, to have like 5 different moving components to make something work, or to design it in a way that's really complicated and hard to disassemble and hard to modify. So it can be a good idea to just step back every once in a while and look at your design objectively and say, okay, this is getting too complicated. How can I modify it to be simpler? How can I change my approach to not be as complex? The most important thing when prototyping is to identify what issues you're having with the design and plan for better designs in the future. That's really what prototyping is about. It's about identifying what you're doing wrong, and improving in the next iteration. One really useful tool that our team uses is CAD, or computer-aided design. CAD is basically a type of software that lets you design your robot virtually before you ever construct it in the real world. CAD is useful for a lot of things. One thing it can be really useful for is prototyping your entire robot before you make it physically. This can help you identify certain problems with your design before you make it and waste time and money on a physical thing. It's great for documentation and organization because it lets you allocate space really easily. virtually, and if you're writing up a notebook and you want to show different iterations of your design, you can just take a screenshot of your CAD from any angle that you want, from any perspective, and there you go. There's your documentation for that part. It also lets you 3D print certain components that might have a more complex geometry than you're able to manufacture yourself. But with all the benefits of CAD, it's worth considering that it's not for everybody. If you are a new team just starting out, you might want to dabble in CAD a little bit for one or two components, but it might be too complicated and too daunting to design your entire first robot in CAD. For a team that's just starting out, just cranking out physical prototypes and working on your bot all physically is probably the way to go. But for teams who want to step up their game and look to compete at a higher level, CAD is a really useful tool for optimizing your design process and for improving your bot in the long run. If you'd like to know more about CAD, our team has another video dedicated around CAD, specifically around Fusion 360, that you can check out. That will be linked in the description below. Another really useful tool that I mentioned briefly earlier is 3D printing and using 3D printed parts in your design. So 3D printing is great for prototyping because it lets you rapidly make very complicated geometries that you wouldn't otherwise be able to manufacture. It's very cheap. PLA filament only costs you about $20 a roll, and a roll will last you most of a season. And the printers themselves can range in price from just over $100 to $500 plus. The printers themselves are a little bit more expensive, but in terms of what they can do for your team, they're definitely a worthwhile investment. 3D printed parts are very easy to change and to modify for evolving prototypes because they rely on CAD designs, and CAD designs are very easy to change. 3D printing is also great for final components because you can modify how strong a part is by increasing the amount of material used in the part. You can reinforce it very easily. And 3D printed filament in and of itself is actually very strong. It's surprisingly strong if you design well enough for what it is. You can make very detailed parts, very complex geometries with them that you wouldn't otherwise be able to manufacture, like I said. But one thing to keep in mind when you're 3D printing is that a 3D printed part is more of a component for a design rather than a full design in of itself. What I mean by this is it should be used in addition to wooden or metal or mechanical parts, not just itself. If you're making a claw for a robot, for example, you might want to make most of the claw out of metal, but then have the little gripping bit at the end to be 3D printed. You wouldn't want the entire thing to be 3D printed because then it might not be as strong as you want it to be. 3D printing is just great because it lets you make very versatile parts for your robot in a very quick amount of time for not a lot of money. After you've gone through enough prototypes and you have a design that works and works well, it might be time to consider polishing up and finalizing your design. Finalizing your design can mean any number of things, from making another version of it that's stronger out of more reinforced 3D printed parts, or CNCing something, or just making it look pretty, to just leaving it how it is. Maybe you have a prototype that's strong enough on its own to work as your final design. That could also work. Just saying, okay, my component's done, it's time to step away from the bot. That's finalizing. Sometimes you're not at that stage when it comes time to go to competition. You're still working on your design, you're still modifying it, and it's not working the way you want it to. When that happens, you need to know when it's time to just step away and say, okay, I've done all I can, it's time to leave the robot to somebody else. Because sometimes you do need to spend time on other areas of the robot, for example, programming or drive practice. You need to consider which one's more important, making your component work well or spending your meeting time letting the programmers make a better program or letting the drivers practice for their competition. Oftentimes it can be better to go into a competition with a not fully finished part, but with more practiced drivers than it can be to go into a competition with a perfect robot but drivers who are practicing on the go. It depends on a situation by situation basis, and it's something to consider when you're wrapping up your design. The last thing I want to go over in this presentation is the concept of documentation. When you're designing a component for your robot, it's really important to document every single step that you take with that component so that you can show the judges what you've done later on and prove that you were the one who came up with the idea. Great idea for documentation is just to take as many pictures as you can. Picture speaks 1,000 words, and it's just a great tool for remembering where your mind was at that time when you designed that part, and it shows the judges physically what you had done and what the part looked like at that stage. Another thing to consider is the changes that you're making between each iteration. It's a good idea to record each of the flaws that a design has and how you're addressing them in the next design so that you can flow between designs easier and show your improvement. And just record ideas that you have even if they don't come to anything. Like, for example, our brainstorming session at the beginning. It's a great idea to record all of those ideas that we didn't go after so that we can show, this is a design that we didn't want to do because X or because Y. Just showing that you're putting a lot of thought into your design and showing the process that goes on behind the design is great for judges to see because it shows that you're learning and it shows that your design is evolving over time. Thank you for listening to this presentation. If you're a team just starting out with the program, then I wish you luck in your development. I hope that you got something out of this presentation. If you're a returning team and you're just looking for some more advice, I also hope that you took something out of this and that you're going to use it to improve your designs in the future. Thank you for listening. Good luck, teams, and have fun designing your robot.